All right. Good evening, everybody, and or good morning, good afternoon, or good evening to everybody out there in television land, or could that be YouTube land these days? So, if you're a fan of the Honeymooners, you know what I meant by that. So anyway, well, thankfully we missed the snowstorm by one day. Fortunately, it affected Eric. He was supposed to speak in Hartford, but the snow actually, forced them to cancel that, unfortunately. So welcome to here. Hopefully some more folks will show up. We have pizza, we have stickers, we have coasters. There's more stickers in case there's one you really want. All right, so this way. There we go. Here's our agenda for tonight, the standard agenda for those of you who are here, our regulars. Thank you, by the way, for supporting us. So we always say thank you to our sponsors because that's, they're near and dear to our heart, and we appreciate their support. We'll talk about what's new, although I didn't have a chance to really update that too much. I'll try to ad-lib that. I'm going to introduce Eric, and then we'll, after his talk, we'll talk about a couple of upcoming events, and we'll leave it at that because I didn't get a chance to go through what our friends of the Garden State Jug are doing this month. I'll save that for next week's meeting. All right, so, oops.
Yep, down to forward, up
the back.
It sounds real good, right?
But then you have to go down with the arrow for the slides and reveal. So of course our gold sponsor is Payara. They are the makers of the Payara platform that comes out once a month, and the platform consists of Payara Server, Payara Micro, and of course they have their Payara Cube offering now, which now includes Payara Cloud. So we thank them for their support. And our silver sponsor is Azul, so we thank them. They are they have their own downstream distribution of OpenJDK. And let's see, we got DevNexus as our partner. DevNexus, as you may know, is in March of next year. So we'll look at. Boris said thank you for sending the 50% discount to registration that ended at the end of last month. So thanks for taking care of that. So our peer meeting sponsors, as you know, JetBrains, we will have a raffle for the November meeting. As you may recall, we gave 3 licenses to the students that did the lightning talks like 2 months ago. Romanelli's is our pizza. They have the pizza for tonight. And then we also, I put Jakarta EE because they provide video conferencing via Crowdcast, so which we used for a while at one point. Our memberships include the Jakarta EE Ambassadors, the Microprofile Working Group, the Jakarta EE Working Group, and Virtual Jug. And Payara did some podcasts earlier this year. I think you've seen this slide before. We were the first one back in January, and Barry and I had a lot of fun talking about what we do, our history, which is 25 years coming up. A little more about that. There it is. We'll be in existence for 25 years in February, and it's been a great journey, I tell you. So we are planning. We've made some progress on this. And so you'll hear more about that as we go. All right, Payara Cube, I mentioned that. Right now, this is a way to deploy your applications, and the Kubernetes orchestration is involved with that. You don't have to worry about writing an app.yaml file. That's an awesome thing. So, all right, the release schedule tomorrow is ramp down phase 1. Which means the 10 JEPs that are part of JDK 26, that'll be it. There'll be no more added, no more taken away. There was one exception to that rule a couple of years ago. And then in March, JDK 26 will be available. Jakarta EE 12, there'll be 24 specs that will have updates. Most of them are going to be removing the security manager, but then others will have some more significant updates. Jakarta Query is now officially part of the platform and the web profile. That happened end of last month, or no, I'm sorry, end of October. You have the Portlet 4.0 and Portlet Bridge. They came over from their respective JSRs, which was part of Java EE 8, which was last updated in 2017. So they will probably be standalone while they're doing this work. And the Jakarta Agentic AI, which was initiated by Reza Rahman, has been approved as a new spec, but it's brand new. It'll take a while. Most likely, it won't be part of Jakarta EE 12. So hopefully 13, we'll see. So let's see, where are we here? Oh, we're at the point where we have Eric here. So put on my readers.
Oh, you didn't memorize it?
What's that?
You didn't memorize it?
No. Sorry. So Eric Deandrea, did I say that right?
Deandrea.
Deandrea, okay. Oh, so D-E and then...
Pretend it's a D apostrophe.
Right, okay, Deandrea. Oh, I like that.
That's how everybody
Okay.
spells it when I say it.
So he's a Java champion and a senior principal software engineer at IBM. And of course, I asked you if you're still part of Red Hat, but on the Quarkus engineering team, Eric has over 26 years of experience designing and building Java-based solutions and developer training programs. He is a contributor to various open source software projects, including Quarkus, Spring, LangChain4j, Dockling, WireMock, and Microx. I think I've heard of that one, Microx, yeah. As well as a speaker at many public events and user groups around the world. Eric recently put his Quarkus and Spring knowledge to use by publishing his first book, Quarkus for Spring Developers. Congratulations. And outside of work, Eric enjoys boating on the lakes of New Hampshire, ice hockey, and martial arts, in which he holds a black belt in Kempo Karate. So note to self, don't mess with Eric. So yeah, on a personal note, Eric had reached out to us in New York and also Connecticut to come visit with us. So we really appreciate that. And so without further ado, take it away.
All right, thanks.
All right. Hope we get some more folks coming here. We got lots of pizza.
All right. I'm just going to give myself a timer because I like to talk, and I'll just talk all night long. So.
Ooh.
All right, let's go over here. All right, good. All right, everyone, thanks for coming. So who here knows what Spring is? That's what I figured. Who uses Spring and writes Spring, puts Spring into production? A couple of folks? Anybody heard of Quarkus? Use Quarkus? Okay, I got a couple fans here. So my career trajectory, so like Mike said, I've been doing software development for about 26 years. I was a longtime Red Hatter, recently moved and transitioned over to IBM. And as part of that transition, I moved from a developer advocate role back into engineering. So I've kind of gone full circle in my whole career. I was a developer, then I went into architecture, and then I went into sales, and then I went into marketing, and then into developer advocacy, and then I just decided, hey, I've got about 10 years left in my career. I just like to build stuff. So I'm back as an engineer. So I work full-time on Quarkus, so I'm paid by IBM to work in the open source. I am a core committer on LangChain4j and for the Dockling Java abstraction as well. I spent most of my career in financial services and insurance before joining Red Hat. I think somebody's over there. Is that door locked?
Oh.
All right. Yeah. I do, so like you're here to learn about stuff. I'm the vice chair of the Boston Java Users Group. So we do meetings like this twice a month and have speakers and so on and so forth. I've spoken at user groups all over the world. I just got back from Morocco. I was at a conference in Morocco. I saw Barry in Colorado a few weeks ago or a month or so ago. So yeah, lots of fun. And Mike talked about this book that I wrote. It's not so recent anymore. It was a couple of years ago at this point, but that's kind of where this whole topic and this whole talk came from. It's a free book. It's not on like Amazon. You have to pay for it. You can just scan the QR code and download the PDF. We used to have hard copies that I would sign and give away, but we don't anymore. So the basics of this book is when Quarkus first came out. We're about 6 years or so ago now, and I was a longtime Spring person, so I skipped Java EE and Jakarta EE completely in my career. I went right from university, so when I was in college, Java 1.0 came out. I started building Spring applications for thick client desktop apps, and then I went right to Spring when Spring first came out. I skipped the whole Java EE thing. For better or for worse, I've heard stories either way.
You're killing me.
But I skipped that, mostly skipped that whole ecosystem. So coming from a Spring background where I was a contributor to Spring, mostly in Spring security, when Quarkus first came out, I kind of, even though I worked for the same company, I kind of held it at arm's length because I was like, well, I know this thing over here and it's really good. What's this other thing over here? And as I started to learn more about it, like everything else that you learn in life, when you learn something new, you always are comparing and contrasting it to something you already know. How is it different? How is it better? And then any new paradigm that comes out, you're like, well, how does this one do it? And how does this one do it? And which one is better? And it gets you thinking. And so I started doing that and I started talking about it. And my boss was like, hey, you should write a book about it. So I essentially wrote a book about it. And now that I've written a book, I'm never going to write another book. If anybody's ever written a book understands that joke, I'm never going to write another book. They talked about an updated version of V2 of this. I'm not interested. It's a lot of work. I was actually paid to do this, and it's about 150 pages. This was 9 months of my life, of 40 hours a week just writing a book. So,
Eric, you know what I said after my first book?
What's that?
I'll never write a book again.
And how many have you written now?
It's up there.
It's up there.
It's up there?
Yeah.
Too many to count in one hand?
Mine took 2 years.
2 years. Yeah, so like people who say, oh, I'm writing a book in my spare time, I totally feel for them. I understand. Like the Quarkus in Action book that Martin Stefanko wrote, it took him 2 years to finally write that. I was lucky enough where I was paid. It was my day job to do it, and still that was 9 months of 40 hours a week doing nothing but that.
Yeah,
It's a lot of work.
Yeah.
It's a lot of work. So anyway, Java turned 30 this year. Hooray, right? Yay, Java turned 30. Oh, the other thing I want to mention is I like to be conversational, especially with an audience like this. When I'm up on stage at like a conference, it's mostly me talk, you listen, but in a group like this, it's very informal. If something sparks your interest, we can take this wherever we want. And we can, if you've got questions or comments, we can do whatever we want here.
And if you do have comments, then really speak up, because I've got this fancy microphone here to catch you, but you have to talk loud.
I never wrote any books, but I did some book reviews. That was a lot more fun.
Yeah. So
It's easier to,
yeah, you get the review, you do it for technical accuracy, then you submit it to the publishers, and they do stuff, and it comes back. It's like, well, you're using the same words, but it doesn't mean the same thing as what it did before. So what you did actually doesn't work because now you've changed the meaning of what I said, and that's not good. But anyway, so yeah, Java's 30 years old. Hooray, hooray, right? But for the last 25 years, this is what we've been hearing, right? It's been dead. Oh, Java's dead. We're gonna move. We've got Rust, we've got Go, we've got Python, we've got all this cool stuff. It's us old farts that are. I'm talking about myself. Us old farts. Nothing about anybody in the room. Us old farts here that are still like, oh yeah, Java's good, Java's good. But if you think about it, we've been saying this for 25 years, and yet it's still going strong. And why is it still going strong? Because of the flexibility of all the communities that are around, communities like this. I mean, I don't know how many there are other like communities where you get people together, you talk about it, you improve it, and it continuously improves the language, right? It's everywhere. Enterprise, especially in large enterprises, you're not going to get rid of it. It's there, and I think it's there to stay.
I like to say that if I had a nickel for every time somebody said Java was dead, I could have retired 10 years earlier than I did.
Yeah. So let's take a history lesson. Has anybody been using Java since it first came out, 1.0?
Yes, but not in production.
In production.
Oh, no.
My first Java production was 1.1, and Swing wasn't even part of the library at that point. It was a standalone library you had to add. Swing didn't come in until 1.2. So if you think about Java, why was it invented? What was one of the main reasons? Huh? Smart light switches.
Write once, run anywhere.
Write once, run anywhere. Because if you think about how we ran and operated applications at the time, sure, it was Unix, but we had Solaris, HPUX, AIX, and however many variants of things that there were, right? And so with C, C++, all these compiled languages, you had to target a specific runtime platform. If you wanted to swap out your hardware, you were kind of toast. You had to recompile, rebuild your application. So there's lots of other reasons, but that's kind of the main reason that I want to focus on. And so when Java first came out, how long was it between releases? Like, how often did you update your JDK?
It was like 3 years.
Well, it came out every 3 years. How long did?
Oh, I see. Yeah, gotcha.
It's like, when did you do an upgrade from 3? Did you go like from 3 to 4? Or did you jump from like 3 to, or 1.3 to 6, or 1.3 to 5? Like, you made these huge jumps, and that were like probably like 5 years in between, right? And then Jakarta came along and said, oh, we're going to build this spec. And no, you can close your ears and go la 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 just for a couple of minutes, because I'm going to pick on Jakarta EE for a minute. Came out with this spec that said, oh, we've got these nice application servers that take away, a lot of the operational concerns for you. You build your application, you deploy it to this thing, and then you can switch vendors. But we all know that that was never a possibility unless it was a huge effort to migrate from like Wildfly or EAP to WebSphere to WebLogic or any of that fun stuff, right? Anybody have to go through any of that? I skipped all that because I stayed out of that ecosystem. So, and those specs, when they evolved, they weren't like higher level concepts. They were like, okay, here's how to do the naming JNDI. Here's how you can do this. Here's how you can do that. And then the implementations came from the different vendors. It wasn't like, oh, give me an HTTP client that I can issue a REST request. It wasn't even in Java until Java 11 that you had something at that level, right? So yeah, Apache HTTP client came around. So, and then we started to move through this shift left thing, and we started to do this thing called DevOps, which was just a rename of what we were always doing before. It's just now we call it something different. We have somebody else on our team that doesn't actually do software engineering for the most part. That's kind of how this evolved. Today, maybe it's done differently at different organizations. The big financial companies that I've been at, this is what we call Agile or DevOps, is we brought somebody in from the platform team or the ops team, and they joined our meetings. And we called it DevOps, but we still threw a thing over the wall and said, okay, here's how you run it. And we cleared our weekends when it was time to deploy stuff, right? But then Spring and Microprofile and some of these other things started to come along and say, hey, do we need these heavyweight, I'm going to say container, I don't mean Docker container, I mean Java runtime container. That came along in these heavyweight things and said, well, do we really need all of that? Can't we just do the same thing where we're not really going to deploy multiple applications into the same runtime? We can separate the applications, where we can separate them by what they do so that we can scale them independently, and all this microservice stuff, if you've been on the microservices bandwagon and read the microservices manual and all that fun stuff. So Spring came along and kind of energized the industry as to how we can do this without following these specs, but we had to learn something new, right? Oops, wrong button. And then came containers in Kubernetes. And what did we learn about that? We're still experiencing that. What did we learn? Anybody running Java in containers? Was anybody doing it before Java 1.8? No? So it kind of sucks, right? Because you have to right size your pods, because Java, with all the stuff that it was invented for, everything has trade-offs. The trade-off of getting this right once, run anywhere is this highly dynamic runtime, which does all this late binding stuff. So when you start a Java process, you've got this huge spike in RAM and CPU at the beginning, and then over time, the just-in-time compiler, the C1, C2 kicks in, and it kind of tails off. But you have to size your deployments and your pods and everything for that initial spike. But if we're doing containers are ephemeral, right? And if you're going to scale, you're not going to scale vertically, you're going to scale horizontally. So now we're paying this price. If we need 4 instances of our application, we're paying it for every instance. And now we can run less things on our, I'm not targeting specifically Springer, I'm just Java in general here. It's been a real pain. So the comment I made about Java 8, if you were running Java 8 in containers, Java 8 was not C group aware, so you couldn't even restrict it to a certain number of cores. So like, Java, we all know Java's hungry and it'll eat all your CPU and RAM, right? So pre-Java 1.8, and there was a micro release, I forget which one it is, it's like 282 or 290, I don't remember which one, but there was a micro release of Java 8 and it was really fixed in Java 9, where it became aware of containers. Prior to that, it would actually look through the container and see the resources of the underlying host and say, oh my God, I've got 372 megs of RAM and 64 CPUs, I can go wild, right? When in reality, it couldn't, you get out of memory errors all the time. So it was not a good experience, right? But this is true today, whether you're in containers or not. Java is hungry. As much resources as you give it, if you don't confine it, it'll just take everything that you've got. So I'm not going to really beat on this a little bit. So if you want to learn more about the way the just-in-time compiler works, but the thought process here is the faster you can get to that warm-up. Sorry, I don't mean to get anybody in the eye. The faster you can get to that warm-up period, which means not just ready to serve requests, but let the just-in-time compiler kick in, let C1, C2 kick in, pound it with some load for a little bit, let that resource utilization go down, because the just-in-time compiler is very, very good. And it is very good about optimizing and rewriting your bytecode on the fly based on what your application is doing. And the time it takes to get fully, using air quotes here, warm, depends. It could be measured in seconds, it could be measured in minutes, it could be measured in hours, depending on what your application is. So it's not just, are you ready to serve requests, which you're ready to do here, right? It's how fast can you get here and be able to stay here. So Simon Ritter, you mentioned Simon earlier, has a talk about this that he did. In this 2 minutes, he spends like a half an hour talking about this, so if you're more interested. Yeah, Mike.
So how's Project Leiden gonna?
So Project Leiden, there's a bunch of stuff in Leiden, everybody says it a little bit different. I don't know all the internals, but I know part of one of the things is called this class data sharing thing, where the CDS, I think that's what it's called. I don't know the specifics behind it, but there's a whole bunch of stuff that's in there to try and basically, if I want to use the word shift left, shift more stuff to build time, more stuff to ahead of time, more so that you can reduce this footprint. And so that's where, and I'm going to say we, I have nothing to do with it, and I can stake no claim for it. We at Red Hat kind of said, well, this is where industry is going. Industry is trying to move this way. How can we do something so that Java stays relevant, right? Because we've been hearing about Java being dead for 25 years. Java stays relevant. People don't have to learn new things. We can still use all the same technologies that came out of all the different Jakarta specs, Jakarta RS, JPA, JTA, all the fun stuff. But maximize, if we're going to run it in containers and we know they're ephemeral, how can we reduce this? Not to say that you have to run it always in containers, but the mentality of containers and the mentality of being ephemeral. How can we reshape, not necessarily reshape the industry, but how can we reshape Java to take advantage of how we actually operate applications today, right? And that's kind of where Quarkus was born from. And that's kind of, it's not like a bunch of people at Red Hat got together and said, oh, we've got Spring, we've got Helidon, we've got Micronaut, we need another framework. No. It was looking at the way we're operating our applications today and how to optimize the runtime for the way we're going to operate our applications, right? So you're probably familiar with this process. You've got your build, typically with Java, you Maven, Gradle, whatever tool you use, package it, and then you run it. And so I'm going to talk specifically about Spring here. Has anybody ever built a custom Spring Boot starter? Do you actually understand under the covers how auto configuration works and all that fun stuff? No? Okay, so I'll talk a little bit about that. So the way Spring Boot, if you built an application, you've got these magical annotations that are on all your classes, at configuration, at controller, at this, at that, at mom, at pop. You've got all these different annotations here. Under the covers, when you bring in a library like Spring Boot Starter Web, just for example, right? It has a bunch of auto configuration classes that have those same annotations, and it'll run through those first. And it creates an acyclic directed graph of an order of all the beans and the things that it has to do. Because there are other annotations like conditional on environment variable, conditional on property, conditional on this, conditional on that, where beans get injected conditionally at runtime based on whatever criteria you can come up with, like properties, environment variables, classes on the class path. Gone are the days, we used to, in one of my previous jobs, we used to add libraries to the app servers, or the Tomcat class path to alter the behavior of the applications when they got deployed into those environments. So you think like someone coming out of college now, like when would the class path ever change? It used to change, right? And that's kind of like a no-no anymore. You don't really do that anymore, right? But it was a cool way to be able to add behavior into different environments. So part of that is this loading config files, class path scanning. So every class on the JVM, if don't know how the JVM works, every class, the metadata for all those classes have to be loaded, and it's stored on the heap. So if you've ever used the reflection package like class.forename or find method or find constructor, there's metadata about every class that's on the class path in the heap, and that takes up some, I'll just say some space. Could be megs, could be 100 megs. It depends on what's on your class path. And then it's got to, Spring in particular has to go through, look at all those classes, look for all those annotations, sort all the things so that, if one bean needs another bean as a dependency, it creates them in the right order. And then it can create thread pools and database connections, and then it's ready to actually start stuff. And you don't really think about much of this because this is all happening in like 2 seconds, right? 2 or 3 seconds. This is all happening. But this is something that contributes to that startup spike, right? Because it's got to create all this class metadata. It's got to do all this stuff to be able to build the application so the application can start serving your requests. Any questions about this? I know I kind of blew through it. So what we, and again, I had nothing to do with it. What we thought about was, well, could we do something where, a lot of this stuff, if I'm going to scale my applications horizontally, so thinking about the container mentality, this stuff is going to be the same for every instance of my application, right? If I don't change my behavior, I'm going to keep the same behavior. This is going to be these 3 pieces are going to be exactly the same for every single startup, right? So why can't we move some of that stuff to the build process? If we know some of the stuff, why can't we do that? If you're familiar with Spring and you know if you've ever done like AutoWired or you inject one bean into another, if you actually put a breakpoint in there, and this is how the CDI spec works as well, most dependency injection frameworks, you put a breakpoint where you have that bean that gets injected. It's not actually that bean, it's a JDK dynamic proxy. It's actually called a proxy class, and then you have to go through several layers of the JDK, which uses reflection to actually resolve the binding, and that's how Java does its late binding, right? You can create these proxies at build time, and then at runtime, you can bind the right class to the right proxy. In Quarkus, what you'll actually see at that injection point is the actual injection, right? We actually write the just-in-time compiler code and kind of pre-warm the application at build time. So stuff that maybe the C1 compiler would do, maybe the heavy lifting that the C1 compiler would do at startup, Quarkus is doing at build time. So where a Spring app might build in 5-6 seconds, a Quarkus app might take 10 to do your build. But what you're going to see at runtime is a much leaner and a much more performant thing. And a couple years ago, anybody ever done GraalVM, native binary, compiled to native? So everything is cyclical, right? My career is cyclical, technology is cyclical, clothing is cyclical, everything is cyclical. So we started off this journey with Java 30 years ago because we didn't want to target a specific platform. Well, now with GraalVM, what does this let us do? It lets us remove the JVM and target a specific platform, right? And why would we want to do that? There's lots of reasons why, but now we pretty much just have Linux, right? So it's not like we have 8 million different Unix flavors. We just have Linux. The only thing we really need to care about is it Intel or ARM. Most of the time, there's ZOS, there's these other variants of things. But essentially, when you compile the GraalVM native image, you're pre-compiling everything, and you're essentially removing the JDK or the Java runtime, and it becomes a platform binary specific to your target platform. So on my Mac, if I compile it, it's a Mac binary that if I tried to put on a Linux box, is not going to run. Or if I try to put it on an Intel Mac, is not going to run. There's still some Java, there's still some garbage collection, but there's no just-in-time compiler. It is kind of like I tell my kids, anybody have teenagers, or have had teenagers? You get what you get and you don't get upset, right? So the thing runs, it starts up super fast, it does its thing, it doesn't really move up or down in memory resources, but you're like everything in computer science, it's all about trade-offs. You're losing some throughput because the just-in-time compiler is gone, there's no C1, there's no C2. What you got at the build is what you're gonna get, and there's nothing else. So for me personally, this was like Kafka was about 10 years ago. Everybody was chasing it because like, oh, this is cool, I gotta do it. Well, what's your use case? Because they're doing it. Well, what's your use case? Many times you talk to someone who's doing Kafka, it's like, well, that really belongs like traditional JMS or AMQ or RabbitMQ or whatever. They're just trying to put a round peg in a square hole because that's what everybody else is doing. I kind of see native images like this. It's very purpose built Like if you need super fast startup, you're gonna run it on an IoT device or a Raspberry Pi or something. You wanna do serverless. You wanna scale up really fast, do some work, and then go away. It's really good for that. But regardless of what Java framework you're using, you're always, if you have a long running application, something that goes up and stays up for days, weeks, you're gonna sacrifice overall throughput for that. And it's gonna take you like 10 gigs of RAM just to build this thing, right? So there's trade-offs and everything, but where I was going with this slide is when Spring 3 came out, was it 2 years ago at this point, a year ago? Last November, I think it was 2 years ago. They made a big hoopla. Oh, we can do this. You can compile your applications to native. You can save all that startup time, but you still have all those trade-offs that I talked about.
What does Quarkus build? What does Quarkus actually brings here?
What is Quarkus? What, I'm sorry?
You don't really need Quarkus to build the ground VM, right? I mean, so what does Quarkus actually bring here?
Yeah, so we're going to talk about that. So, but where I was going with this native thing is Spring had to retrofit 20 years of reflection, because essentially the Spring framework is completely built on JDK dynamic proxying, which goes completely against this ahead of time compilation thing. Because if you don't have a static compilation thing, GraalVM will say, oh, you don't need that class. I'm going to throw it away off of your class path. It does dead code elimination. And so then you have to go back, and if you want to do reflection, you have, as part of your build process, you have to tell GraalVM, hey, I actually need that class, or I need that method in that class. Don't throw it away, because I'm calling it reflectively, right? So essentially Spring went through and marked all their class, and you'll see more of this in a bit, but they essentially went through and marked most of the framework as don't throw it away because we need it. Whereas the design of Quarkus, that kind of this being able to build a native image was almost like a side effect of how we designed the framework in the first. Again, I say we, I had no part of it at that point. I wasn't a contributor at that point. Then I'm going to talk about the goodies in a minute. So anybody doing reactive programming? Anybody ever use Spring Webflux or RxJava or any of those reactive libraries now? We can have a talk about that over a beer. How's that? Virtual threads solve all problems, right? Just like the cloud solves all problems. Right. Different conversation for a different talk. So this reactive programming model really came out of the different ways in the threading models for applications, right? The blocking model is essentially on a web application thread per request, which seems good, but it doesn't scale, because every time a new request comes in, you have to either start a new thread or grab one from the pool. The thread size is limited based on memory and all that fun stuff. Reactive programming goes off of this non-blocking I/O, where you have very little threads, and you can utilize those threads better, so they scale a lot faster, or a lot better with a lot less overhead. The challenge is the programming model here is super hard, and if you're not familiar with it, it's kind of like you have to wrap your brain around it. And in most of these other frameworks like Spring, when you have to make this decision, this architectural decision, before you've written a line of code, right? Before you even create your GitHub project, because the libraries you're going to use are dependent on which choice you make, reactive or blocking. Quarkus doesn't care. You do both, even the same. You have one method that's fully reactive and one method that's fully blocking. Under the covers, it's completely non-blocking using the event loop model, but it handles all the threading and the thread delegation for you. I'm going to do a demo. We're going to talk about the demo, but this is something that's very unique to Quarkus, and it's not a plugin. It's not like you need an ID, special ID feature. It's just part of the framework itself. Anybody ever do Node.js programming, where you kind of start your dev server, you just code, see my results, code, see my results, code, see my results? We got it. You need a Postgres server or Kafka broker or an OpenID Connect thing. You just have the dependency in a class path. Well, it'll just start up a container for you automatically. You don't have to do any test container stuff yourself. It's just there. You want to know if you make a change in this code, do my tests pass? It'll just run those tests automatically in the background. It understands the relationships between your code and your tests. So if I make a change to one method, it's only going to rerun the tests that are affected by that change in the background and give you instant feedback in the development. So I'm going to kind of show off some stuff. But at the end of the day, we're still talking about Java. We're using all the same libraries that you're probably already using out there. One question I get, like, so Hibernate, for example, or I like to pick on Hibernate and Jackson. These are two like very reflection-heavy frameworks that have been around forever, and everybody uses them, right? People ask, well, how do you do it for Hibernate? Do you have like your clone of Hibernate or a clone of what was it, Jackson? Sorry, I'm getting old. I can't remember things. The answer is no. It's the same binaries in Maven Central. The difference is what we call a Quarkus extension, which is kind of synonymous with a Spring Boot starter. There's always two parts to every extension. One part is I don't want to say wrapper, but for sake of understanding, I'll call it a wrapper, so like a wrapper around Hibernate. The other part is the build time adaptation. So for Hibernate specifically, Hibernate you can configure lots of different ways, right? You can do persistence.xml. In Spring, you can do bean configuration. There's lots of different ways to configure Hibernate. Well, if you don't use persistence.xml, or even if you do use persistence.xml, those XML parsers and libraries stay on your heap in your class metadata forever, right? Because all that stuff is done at runtime. All the building up, all the queries. Anybody ever use Spring Data JPA? You know, it's kind of like voodoo black magic. You just, in your repository, you just invent methods. You know, it's an interface. You invent methods, and by the name, find, person, by, name, order by, and magically you get something that works, right? That's all done at runtime. It's building all the Hibernate queries, and it's building implementations of all that stuff at runtime. Jackson. But it does, JSON serialization. So if you're doing like Spring MVC, or even just plain Java, HTTP, and you're using Jackson to do the marshalling. All that building of the marshallers and the serialization, deserialization is reflection heavy, and is all done on the fly at runtime in every Java application. And it doesn't have to. In Quarkus, Jackson, we optimize it so at build time we can see what things you're sending over the wire, and we can statically build and compile serializers and deserializers at build time and include them in your application. So there's no more reflection in your application happening. Hibernate, that persistence.xml, even if you use persistence.xml, we read all that stuff at build time, and as long as we see that your application doesn't need XML parsing, we'll just toss the XML parsers and all the libraries so that we don't need them on the class path, because we can build all the Hibernate domain models and all the stuff that Hibernate needs at build time. We can write it to the Git code. Because we have this model, it allows us to do a lot of different things. And so I'm a huge Star Wars fan, so some people start saying, well, is it really, are you just like doing some magic, or what's actually happening under the covers here? So I like to call it the secret sauce. So some of these things are practices, and some of these things are technical things that we actually do. And so the first thing is more of a practice. Don't be dynamic. So what this means, so whenever we're doing stuff in the core of the framework, and we come to a choice where we can allow for flexibility or runtime override, take a step back and think about it and say, is this something that the user should really override at runtime? Does it change the behavior of the application? Everybody knows with Spring Security, you could just through configuration, when I run it on my local laptop, I can disable all security, which is what we all do all the time, right? And then when you put it in production, it's using like Amazon Cognito or some OpenID Connect server, and you haven't touched the code. It's all done through configuration. Our kind of thought process around that was, well, that's a behavioral change. And if you're going to do a behavioral change, those behaviors should be tested and should go through all of your pipelines and should be tested, and they should be separate artifacts, right? That being said, things like sizing your database connection pools or URLs, usernames, passwords, all that kind of stuff, absolutely. Change it at runtime. It belongs environment variables, secrets, whatever, right? But don't always, whenever there's an opportunity to allow for dynamicism, is that a word? Dynamicism? You know what I mean? Yeah. Take a step back and think about it. And then really decide, does it need to be dynamic or can it be fixed at build time? So, and kind of an example, and again, I'm picking on Hibernate again. So the Java Transaction API. I thought I said I skipped Java EE, so just take it on faith. I've done some reading, right? So the Java Transaction API, at the time that these slides were written, it might be different now. There were 129 implementations of the Java Transaction API. And if you actually look at the Java Transaction API source code, what do you think it does to find the right one? It's simple. It's not a trick question. For each class.for name, catch class not found exception. If I get class not, then if I find it, then break out of the loop, and I found the one, yay, right? Well, we know at build time which one you want, right? Why do we even need to do this, right? So if you're not familiar with exception handling, do you know what so just to kind of hit on this a little bit more. There we go. Class not found exception. So you think of a try catch, class.for name, catch class not found exception. What does it take to actually create an exception in Java? Has anybody ever looked at the throwable class? What does it do?
Throw an exception. You can send in.
Well, but to actually create the object, the throwable object, what does it do?
Oh.
It has a method that has to compute a stack trace. And that computation is synchronized. It has to block all threads to compute a stack trace for that exception. And in this case, it's never looked at, never printed, never anything. So anytime you create an exception in Java, it stops and pauses all of your threads to compute a stack trace, regardless of anybody ever said. There's some overloaded method signatures that you can use or override to not do that, but the general implementation, if everybody just creates their own exception class and just calls super with a message or super with the exception, that's what it does.
So, so just like C++, it was stack unwinding, right? You throw an exception at wherever you are, but then it goes through and unwinds.
Well,
how
throwing
you
the
got
exception
there,
is
right.
different. It's actually creating the
the
object itself.
Oh, okay.
So the object holds the stack trace reference. If you look in the throwable class, there's a method, it's a protected method called fill in stack trace, and it's synchronized.
Okay.
Which means all the threads have to block so it can compute what that stack trace is when it creates this object. In this case, we don't even care about the object,
Huh.
right? So just a little tip. So dead code elimination anyway. So GraalVM, when you do native compilation, does this heavily, regardless of Quarkus, Spring, Micronaut, doesn't matter. Anything you do with GraalVM is going to do a lot of this. But I kind of alluded to already with the Hibernate example and the Jackson example, Quarkus can do this as well. So if you think about database, so everybody does this in Spring, right? You have both H2 database and Postgres and Oracle and SQL Server all in your class path, right? Because during your tests, you run with an in-memory database, but when you deploy it somewhere, you actually connect to a real database. Has anybody ever written a query where it passes in your test, but when you deploy it to an environment with a different database, it fails, it blows up? You're laughing, so I'm going to say you've done that before. Someone back there, right? Because the dialect, it might be non-ANSI SQL that you wrote. You might have used a function that was specific to Postgres but doesn't exist in another database. So kind of the mentality here with the whole microservices and shift left is build your applications and test your applications with the infrastructure as close to production as possible, right? So if you think about all these unused, if you got 3 different database drivers on your class path, you got all these unused classes, which the class loader had to index, had to create all the metadata for, and are now on your heap, and you're never going to use them, right? It's just taking up space in memory. So the just-in-time compiler has to read them, has to decide, and then say, you know what, these aren't used, I don't need them, let me kind of garbage collect them, throw them away, but the metadata is still there on the heap, right? So like example for Oracle at the time I did these slides, this happens every single time. So there's like 500 classes in the Oracle JDBC driver that if you're not using Oracle, but you just have the driver in your class path, all this is there, right? So you think about method dispatching. Maybe you have an interface and there could potentially be multiple implementations of that interface, right? At runtime, the just-in-time compiler has to, what we call megamorphic dispatching, has to figure out what the binding is to this, binding the implementation to the interface. And there might be others that out there that you just don't care about because they don't match the criteria. Whereas in Quarkus at build time, we can do the matching at build time, and we can say this goes with this. And for some, not for everything, there's still some flexibility, but for the most part, we can do this and we can toss the rest of the things that we don't need. Yep. It's class loading. It's just not even bringing the classes into the artifact, into the jar.
Just having the jars around and having it in there.
Yeah, so like for example, if you've got 3 JDBC drivers on your class path, based on your configuration, we know which one you want. So we can just not include the other ones during the build process, right? Because you shouldn't have imports to them. If you do, that's probably a bad practice that you shouldn't be doing anyway. That's why we have interfaces, right? So the big part of this, so the core framework does this, but what about third-party libraries, right? What about things like, we don't want to be in charge of the world for every library that's out there and making every single library efficient, right? We need an ecosystem. And to have an ecosystem, we need a build process that what we call extensions or extension authors can reuse that provides this to them, this ability to examine what's going on and to do ahead of time stuff, right? So we have a pretty decent build process. Now, I will say, if nobody's written a Spring Boot starter before, I won't say trivial. It's trivial to do trivial things. The building an extension is it's got a little bit of a learning curve because you kind of have to take a step back and understand how Java compilation works. A lot of times Java compilation and the just-in-time compiler can take shortcuts. It can see, oh, you've got this attribute and it's used here, 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 here. I could actually make it the compiler says, I can actually make it static and I can just take its value and drop the value in here so it's not by reference anymore. And even though your code is by value, the JVM actually does it by reference to save space, right? So we can do things like that at build time as well. So indexing is interesting. So we've talked a little bit about reflection and how reflection works, but if you think about frameworks specifically, with the reflection API, you can do like find all your classes or find your constructors or find your methods or find methods that match a parameter or construct new classes or instantiate classes through reflection. But if you think about like Spring or Micronaut or whatnot, has all these annotations like at control or at repository, at configuration, and then at bean. And so it's essentially like I need to find all classes, interfaces, or methods that have a certain annotation. Or I need to find all classes that implement an interface or that have a certain method. The reflection package doesn't give you anything. The JDK doesn't give you anything for that. So different frameworks have to do this in different ways, and they all use reflection to do it. Because you can find this by combining, taking the things the reflection API gives you, and like first searching for all your classes, then searching for all your interfaces, then looking through your inheritance hierarchy. But you're going to do that every time, right? Because unless you cache it, you have to re-examine that every single time. What Quarkus does is, oops, click the wrong button here, sorry, is we have this thing called Jandex, which is actually a separate library. It's not part of Quarkus, it's part of a separate project, a separate open source project that we use, but we run it at build time. And we can statically index everything, every line of code, every class, every annotation, and we can offer that out to the extension authors. So if you want to find, give me all the methods that have a certain annotation. Anybody remember big O of N from computer science classes? That's a linear operation, right? Because all of this is all pre-indexed during the build process, right? Big O of N or big O of 1, I guess, is the thing, because it's a linear operation.
The Holy Grail.
The Holy Grail is what everybody tries to, what every sorting algorithm tries to get to, right? So we can do this, we can even offer it at runtime. So rather than having to do reflection, our extensions can actually look things up in the index, and rather than having to use the reflection API. So you'll see I've got some statistics on a slide. We do very little reflection in the framework. If pretty much close to zero. We do zero reflection. And we even, if you were to look at some of our code, you'd say, was that code written with like Java 1.4? Like, because we don't use lambdas, we use anonymous interclasses. Because if you think about writing a lambda has overhead. It might be minuscule, but the compiler actually has to generate, the way it generates the bytecode is different, and it has to load, that lambda now becomes a separate thing that the class loader has to load. So it might be minuscule, but when you've got thousands of classes and you might have 3, 4, 5, 10 lambdas in each class, like that 0.001% on a huge scale starts to add up. So we just don't do it, right? We don't do it. For code that's at runtime. Code that executes at runtime, we don't do it. Code that we write that only executes at build time and then gets tossed, we don't care about as much, yeah.
Say Quarkus is a framework that is particularly targeting like a low latency applications or something, because for most applications those extra milliseconds like lambda versus in the class probably don't matter all that much, but if you're doing like a low latency trading, maybe it does or something.
It's not, I'll show it in a little bit, but it's not just like startup time, it's memory usage. You'll see a typical Quarkus application uses a half to a third of the amount of of RSS or RAM that a Spring app uses, and you get about 4 times the throughput from a single instance. So we said it was born out of containers. You don't have to run it in containers. It's just a JVM. It runs on a JVM. So libraries that don't have extensions still work. Like, does anybody like Lombok? I always bring up Lombok. Lombok and I have a hate-hate relationship. We don't get along. I don't recommend it to anybody, but people love it. So things like that don't have extensions, they still work. Now in native, that's a different question.
Records, you don't need Lombok, right?
That's right.
Yeah, with records, you don't really need Lombok. But so, what was I saying? Yeah.
Trying to understand what Quarkus actually is or something. Is it
It's a framework like Spring, so you build your application on top of it. And it's an and I'm gonna do some coding once I get through this. Oops.
So is it like you would use it instead of Spring?
Instead
or?
of Spring, yeah.
Okay.
You'd use it instead of Spring, or instead of Jakarta EE.
Yeah, but Spring uses Jakarta EEs.
Well, so we use the APIs too. So Quarkus standardizes. So if you're going to do dependency injection, you're going to use CDI.
Yeah.
But Quarkus has an optimized version. I don't want to say a version or a fork of it. It takes CDI and it applies this build time adaptation to it, right? So it's an optimized. It's not the same. It's not like the Weld implementation that you see in like Wildfly. It's a different implementation, but it's still the spec. It passes the TTKs. And all that. Same with like JPA spec. And if you're going to build a RESTful application that takes REST requests, you're going to use Jakarta RS. So you're going to use all the different specs that come out of Jakarta, but it is not a Jakarta EE application container. It doesn't intend to be, it doesn't want to be, it doesn't pass all the specs. It's more of a microservice-y kind, and I don't want to scare people off and say you can only use it for microservices. It's just for small things. But if you want to build a monolith, it's just a Java app, build a monolith. Have at it. Right. So this is kind of a practice. Don't make humans tell the computer what it should already know. Everybody familiar with this one? Everybody hates this one. Like, I'm in a class called thing. In every class I have to define this thing, and I have to tell it what this thing is when it should know what this thing is because you're inside the thing, right? Wouldn't it be better if you could just do this, right? And because we have all the build time adaptation, we can rewrite your class at build time to actually look like this. So under the covers, if you were to put a breakpoint, this is what your class would look like. We can do all that augmentation at build time. So this opens up the door to being able to do lots of other cool things. We can build whole classes at runtime. We have a whole framework for build time, actually creating new classes with functionality and adding them into the compilation. So we can build where, like the Spring Data JPA example, where at runtime it constructs a proxy instance using the Java proxy API of how to implement a class. We can actually implement it statically at build time that has a static compilation, implements interface, and then inject it as a bean, bind it in the just-in-time compiler, and it's out there, right? So there's no proxying done. We can build the implementations at build time. That's how we do we call it reflection-free serializers in Jackson. That's exactly what we do. We actually build the classes and the martial art classes at build time. All right. I think this is the last one, and this is another practice, continuous profiling and shaving. So we have a team of people that are kind of like dogs on a bone, where we take like milliseconds seriously. We profile every single time, and just this week, we've open sourced everything. So all of our performance lab scripts, and I'm going to show them to you, everything that we do in our internal lab. The only thing that's not open source is the lab environment itself. Like, that's protected and private, and we use Jenkins for it. But the scripts that the Jenkins job kicks off is all public domain, open source. The results, every time we run a job in our performance lab, it automatically publishes the results to GitHub, and we regenerate images on the fly, and they're all in the public GitHub, and I'll show you where they all are. And we compare Quarkus 3 to Spring Boot 3 and Spring Boot 4. Short note, Spring Boot 4 is worse than Spring Boot 3 in terms of performance.
Really?
Yes. Yes. Because like everything over time, the older it gets, just the more stuff you get. You kind of hoard and you collect stuff. I know my basement, I've lived in my house for 15 years. I've got a lot more stuff in my basement than I did when I even have boxes that I haven't unpacked like I said to my wife, do we even need these anymore? She's like, don't throw them away. Like, we haven't opened the box in 15 years. There can't possibly be anything in there that we need.
So has anybody figured out why Spring Boot 4 is less performant than 3?
I don't know. Not my job to look into.
Okay, no, I'm just curious if you happen to know, I mean, because I don't know if it's the J specified annotations, for example, you know.
I don't know.
Yeah, and, okay, something to look into.
I don't know. I just got that working yesterday, the comparison, so not my job to look into. I just know it's good for us. Right? And I kind of alluded to this, be reactive under the cover without forcing real people to do reactive or virtual threads. Someone brought up virtual. If you want to do virtual threads, great, do virtual threads. You know, do all or nothing, do one method, have at it, do whatever, mix all three in one class, and sure, well, it all just works, right? And so, what if I told you that if anybody has any idea of how much their organization, it costs them to run all their Java real estate, probably in the millions if it's a large organization, millions of dollars. What if you could cut that cost in half? Or 70%. You could go back to your boss tomorrow and say, hey, we could shave 70% off of our operational costs, right? I'll take a finder's fee. So let's do some code. Any questions on that? I'm going to do some live coding now.
You have existing Spring application, how hard would it be to convert it to Quarkus?
Excellent question. That's exactly what I'm going to do right now. And I'm going to build a whole new application from scratch, and I'm going to do it in about 10 minutes. So, but first I'll show you the application we've got. Is this big enough for folks in the back? Should I switch to light mode? Because if you don't say anything now, I'm going to keep going, and you get what you get, and you don't get upset. Kind of like AI. I said, if you talk to it like it's a 12-year-old and try to get it to do exactly what you want, nothing more, nothing less, like it's a 12-year-old, you're good.
What does everybody in the back think? I can see here, but I'm sitting close.
All right, good. As long as nobody's yelling. So I'm going to do, should I do Spring 3 or Spring 4? I've got both. I'll do Spring 4. So Spring 4 just came out. It's the shiny new widget that's flying through outer space. So I've got this application here. So Spring Boot 4 brings in lots and lots of extra dependencies. So one thing I found out when I converted my app to Spring Boot 4 is there used to just be Spring Boot Starter Test, right? Which had a whole bunch, and a Spring Boot Starter auto configure. Now they've separated it out. So if you do Spring Boot Starter Web, you have to bring in the Spring Boot Starter Web test. There's an equivalent test dependency for every starter. So like your pom.xml, your Gradle file now basically explodes. So there's a lot more stuff in here. So I've got a Spring Boot application which has a data model. So the data model, it's kind of simple, kind of complicated. So we have fruits. So I have a fruit, which the object is pretty simple. It's got an ID, a name, a description, and then it has a relation to a thing where we have prices. And the prices belong to stores. So we can have fruits and we can have stores. So we've got two entities, right? Fruit stores, and stores sell fruits, and different stores sell fruits at different prices. We're using JPA and level 2 caching for performance. So we've got L2 cacheable. We've got somewhere in here, there's a caching thing. I wanted it embedded. So we've got natural IDs, embeddings, all kinds of fun stuff. Yeah, here we're doing like select fetching and caching, and so you can read all about how to do L2 caching, hibernate, level 2 caching, and all that stuff. But essentially, when you do a query, it keeps them in memory and it caches them for a period of time. So if you're querying like the same fruit over and over again, it doesn't have to go back to the database every single time, right? And then just some objects that represent. But those are the two main entities, and then some relationships between them. Not super complicated. And then there's there's a data.sql file, so when you run it locally and it creates a database, there's some data. The configuration, I'm going to do Postgres, and then you've got the L2 configuration in here to get the level 2 caching. You've got your main application class. But then to get it to work in native, this was actually a challenge. So actually not even a native, to get level 2 caching, you've got to do all this configuration here to get all this stuff to work. So there's a bunch of, I'm using caffeine. So I wanted to keep this as simple. So I know what Quarkus does, so we built this Spring app to kind of be almost identical. It uses the same technologies, does the same thing. It does the same level 2 caching. So I'm going to build the Quarkus equivalent that does the same thing. So we're using caffeine, which is a really good in-memory cache. You could use EH cache, but we picked caffeine because that's what Quarkus uses, and we wanted to keep it similar. So there's some configuration you got to do. And then if you want to do native compilation, you have to do like that GraalVM stuff. There's stuff that you have to tell GraalVM that, hey, don't throw this stuff away. I need it. So you have to build some of these runtime hints for the L2 caching and for Hibernate itself. You have to tell it, because this is actually a bug I filed on the GraalVM reachability yesterday. This is a workaround for a bug that's out there now. So there's that. And then the rest of the code, I've got a repository. So I've got my interface, and I've got, with this magical method that you can find stuff by name, right? And then I've got my controller class, which looks pretty standard. It injects the repository, has a get for a specific fruit, and it has a post where it does transactions and creates a new fruit. So pretty simple, right? So if I run this thing here, so if I do, make sure I'm in the right directory here. Oops. I do Maven, Spring Boot, run. Oh, I actually got to start a database. All right. So I have a script here which just starts a database for me. So this repository actually, this is the performance comparison repository that I was talking about earlier. So if I come back over here to the browser, right, all this is here in this repository. So this is the Spring Boot 4 app. Under scripts, there's like if you want to measure yourself time to first request, or you want to stress the system with like WRK or WRK2, there's a script for stressing, running basically a load test. And then in this perf lab folder is all of our performance lab stuff that we've open sourced. So there's the script which runs the actual benchmark. It's got lots of options, so we can configure, we can limit it to so we do CPU pinning. So in our lab, we've got a huge set of machines with like 128 cores and hundreds of gigs of RAM, and we can do CPU pinning. So we can pin the database to just these CPUs and this section of RAM. We can pin the app, and then we can pin the load generator. Something you're not going to be able to do on your laptop. So when you run there's this like fallacy of benchmarks, and the first fallacy is don't ever run it on your local laptop because you get inconsistent results. And the problem is if you're doing a database, an app, and load generation, especially on a Mac, you can't. Everything is competing for the same resources, but in our lab we pin everything nothing competes with each other in the lab. And so, but you can configure, you can change how much memory is allocated to it, how many cores each thing has. It's pretty configurable, and we can just do that for each run. Oops. Right. Yep. So those are all the scripts, and everything is there. So this app is actually right from there. So if I do scripts and I start the database, and now I run the app. Oops. I'm using Java 25, by the way. So the app is up, and now I can do right, and I get some fruits, and you can see it's what we wanted was something that goes through all of the relations. So it basically has to call both entities, it has to do the relations, and it has to return a payload which has the combination of all the entities. So it has to fetch and do all the joins and fetch from all the tables. So it has like, okay, here's my mango, my exotic tropical fruit. It's priced at $2.99 at this store in Paris, France, and it's actually 2.99 euros. It's 3.99 in Sydney. So it's sold at all these different stores at different prices, right? But it's the same fruit. So the fruit is kind of like the top level entity that we're fetching here, right? And so if I wanted to actually load test that, let me stop the database. So if we look at this load test script, so I am going to run it on my machine, but again, take it as a grain of salt because everything is competing for the same resources. So essentially I have a script here. It's going to start my app. It's going to give it, so it's going to do the best thing it can to constrain it to 4 cores. So the app will only have 4 cores, but those cores could overlap. They could be the same cores that other things are using, right? They're not isolated just to the app, but I'm constraining the app to 4 cores because like I have the slide, Java's hungry. If you don't constrain it, it'll just use everything you got, right? And then 512 megs of RAM. And then it's gonna run, the WRK is a well-known benchmarking tool out there. It's gonna run 2 threads with 100 connections for 20 seconds, and it's gonna pound with anything that takes longer than a second to come back, it's gonna consider a timeout. Right, so if I run this, stress, so the script starts a database. Oops, I think I got it because I ran. I think I'm going to run it from there it goes. All right, so the app is up and now it's starting to, I don't know if you can see down the bottom here, but it's starting to stress. And it'll print out a report of like any errors or connections, but basically it's essentially a throughput test. Like how much throughput can this instance handle? And then we'll go build a Quarkus version of this. 20 seconds. All right, make this bigger here. All right, so the first thing we noticed is there were 288 connection errors. That means that under this load, there were 288 requests that just couldn't be fulfilled because the application was too busy, couldn't do anything, right? So 288 of those requests got rejected. And overall, over that 20 seconds, it was able to handle about 1,400 requests per second, right? Based on that load. Again, it's on a laptop, take it as a grain of salt. Like if I were to run it again, it might be completely different. I'm not gonna run it again because I don't want to take 20 seconds, right? So we'll keep that here and I'm gonna go off and I'm gonna build a new application here. So I'm gonna do a new project. I'm gonna say Quarkus. I'm gonna pick a different place to put it. Desktop, garden state jug. And do. It's built in. IntelliJ has built-in support for it. We actually have a weekly or monthly cadence with JetBrains where we talk about what we're doing and what they're doing and collaborating on what things should be. So like property file auto completion and template complete, like basically the same stuff that the Spring Boot has for their stuff. So how is that gonna do it? Code. So now let's think about what this application does. So I know I need a REST layer with Jackson. I know I need Hibernate, right? Because I need Hibernate validator and I want Hibernate ORM. What else was in there? Postgres, right? I need a Postgres driver, JDBC driver. Is there anything else that I needed? I think that about covers it, right? Yeah.
The latest Quarkus too is.
This just came out today, so I'm living dangerously. So for us, like a release is like a non-event because we do it every week. It's just like, yeah, we did the release. I pushed the button and it did its thing. It's a non-event. There was one week we did, I think, 4 releases because we have like an LTS, so we do 6-month LTSs, and we had to do like a back port plus a new release in the same week, and the Camel guys like screamed at us like, We can't do 4 releases in a week, like to keep up. All right, so we've got our app here. So I'm gonna flip back and forth. So I'm gonna look in here, and I want to keep the same structure. So we've got source main. Oh, so the first thing I'm gonna do is I'm gonna run this. In dev mode. So Quarkus, like I said, has this thing called dev mode. You notice there isn't even a line of code in the project. There's a properties file, but it's empty. I'm actually going to rename it to, oh yeah, Maven's going to download the internet because I had to wipe out my Maven cache yesterday. I had some, I like YAML. That's another extension I need to add. So my dev mode is up. I forgot to add an extension, so I'm going to say, I have the Quarkus CLI. I'm going to say Quarkus ext add config YAML. Oops, cross my fat fingers. So the application's already up. It's running in dev mode. I can add new dependencies. It doesn't matter. It just stays up. So the first thing I'm going to do is I'm going to hit the D key here, and you get this little developer UI that comes up. And so when you add these extensions, each extension can add what we call a card to the developer UI, which is only available when you do dev mode. So for example, like because I have a JDBC driver, I got a database table viewer that I can actually query, and I can mutate, and I can add data. And as I start to add like JDBC entities or JPA entities and modify them, it'll rebuild the schemas and the data on the fly for me while the app is up and running. So I don't have to. So different extensions like Kafka, for example, if you're doing Kafka or AMQ, has like a topic browser, and you can see messages that are on the queue. You can add messages to the queue and trigger consumers and all that fun stuff. I don't have a lot of interesting things in my app right now, so there's not a whole lot here. But yeah, you kind of see what's going on. If I want to look with HQL, it'll give me the HQL console. So different extension authors can keep this in mind when they're building extensions. They can also build these kinds of things into it, like LangChain for J and the AI extensions. You actually get a chat browser in here, so you don't have to build your own. Even if you're not building a chatbot, but you want to play with your AI integration, it'll actually give you a chat interface, so you can play with your AI stuff, or your RAG pipelines and all that fun stuff. There's lots of stuff in here. So the other thing that's in here is called Dev Services. So you notice there's a Postgres container that's running, and it's bound to my app. I didn't start it. Quarkus does it for me. I don't have a single test containers dependency on my class path, but Quarkus through the extensions can also do things like start containers, bind containers. Sometimes a container is a single instance and related only to that app. Sometimes you might have 2 apps, like one's a producer, one's a consumer, and you want to share the broker between them. So the first app that you start will start the container, and the last app that you shut down will stop the container. They can communicate to each other. So the other thing this lets us do is I can start to build. Where's my Spring app? No. Where'd my other app go? There it is. So now if I go, I'm going to create source main resources. So I'm just going to grab this data.sql. I'm going to copy it blindly. And I'm just going to drop it over here, right? Paste. My application.yaml, I have to add a few things to it. Oops. So I'm telling it, configuring some Jackson stuff. I'm telling it to use the reflection-free serialization layer, and then I'm configuring the database. But you notice there's no Hibernate H2 configuration in here. The Quarkus extension will automatically determine based on the annotations on my class that I want to do second level caching and level 2 caching, and it'll just turn it on for me. I don't have to configure it. I don't have to do anything. As soon as I bring in my entities or create my entities, it'll just do it for me. And so now that we're talking about entities, I can just grab org.acme.domain. I can just grab this whole package here. New package. I can just paste the whole thing. So exactly as it was before, and it just works. Now I can come back to my dev UI. I can come back here to my database viewer. And now I have tables, right? Oh, in Quarkus, it's import.sql, sorry. Right. I can just come back over here, refresh, and now I've got data, and I can see my data, and I've got my tables, and I've got everything there, right? I haven't restarted my app. I haven't rebuilt anything. It's just kind of working on the fly. So I've got my data model here, and now I can start building around my data model. So what was the first thing we did? So we've got a repository class, right? Notice the other thing I don't have like the application class that you need in Spring. You don't need it. It's not there. I don't have any of those runtime hints things. Quarkus takes care of all of that. I don't have to worry about GraalVM or any of that stuff. It's just doing it for me automatically. So now if I create a a fruit repository class, right? Right. So the first thing I'll do is I'll tag it. So Quarkus uses the CDI, the context dependency injection spec. So application scope is kind of like singleton. It means there's one instance for the app. That you might ask, well, why is there a singleton annotation? That's a different conversation for a different day. But we always say use application scope unless there's a specific reason not to. And I can say implements panache repository. Right. And so panache is a Quarkus thing kind of similar to Spring Data JPA, where the repository gives you all your CRUD operations. So if I bring up, oops, I called it, actually I'll keep it misspelled because I don't feel like renaming it. But you can see I've got all these operations, count, find, all these things, and all these implementations based on the thing here are built on the fly. So it's built on the fly. The implementation is built on the fly at build time, compiled, and it's part of the bytecode. It doesn't have to do anything at runtime to create this. And so what was that other method? Find by name, right? So I can just take that. And notice here it's a class and not an interface, so I actually have to implement it. Public, but I can just say, oh, yep, see, tell it the AI thing already knows what I want to do. So I can say, fine, I don't have to write the full query. If I'm just writing a select where I want certain where clause, I could just say what parameter I want and what I want it to be equal to, and just return it. And it'll build the query at build time for me and implement that method. It'll actually put an at query annotation on the thing so that method always has a statically compiled query. Yep, you can do native queries. Yep. Named queries, native queries, all the stuff that you can do with JPA and Hibernate, you can do here. Right. All right, so that layer is done, and now let's build a controller. Right. So I'm just going to go over here because it's easier for me just to, I don't remember all the operations. I'm just going to grab that. Right, obviously it doesn't compile, so we're going to do some, so instead of REST controller, so I'm going to say this is at path, which comes from the Jakarta RS spec / fruits. Of course, I misspelled my repository class name, so I got to misspell it here too, right? Right. So where Spring has
always make an even number of mistakes.
Yep, even number of mistakes, right? So I can say this is an at get. So in Jakarta RS, there's separate annotations for each thing, whereas in Spring, like get mapping, you can put all your produces, consumes in one annotation. In Jakarta RS, I have to say that produces media type that application JSON, get rid of that, and instead of find all, it's list all. Right, that method's good. Now I can say this is also an at get, but to a subpath to name, produces media type. That's good. Instead of path variable, it's what's the annotation here? Path param. Right. And instead of response entity, because it returns 4, we can have a different conversation another day of whether a 200 with an empty body is the right answer or a 404. To me, 404 is the right answer. In REST, if you ask for something that doesn't exist, you get a 404. If I don't have that resource, you get a 404. But we can have a beer and we can discuss that later. But that's how I do it. So we'll just call this response, right? And so find by name returns an optional, so I can just say this is going, instead of response entity, okay, this is response, okay, or else get response status, and I'm just going to put in 404, and then dot build, right? So now we have a post. At post that produces, that consumes. Now this is gone. Transactional stays, valid stays. We don't need response body because anything that's not something else is the body, right? If you want other parameters that aren't part of the request but you want to inject, you can inject them with the @inject annotation or @context. But anything that's not a parameter, is not contextual, is the body, right? You don't need to tell it that it's the body because it is. And I can just say, is, I think, persist. I'm doing this off the top of my head. Persist. And then, so you might say, well, that's interesting. How come persist returns void? And this comes to, if you actually understand the JPA spec and you look at how the entity manager works, the entity manager persist operation is void because the way Hibernate works is it keeps everything in a session. The transaction is part of a session. You persist the object. You don't get anything back. Okay, Hibernate persists it. Now you have a reference to that object, which is fully persisted. If you actually look at the Spring Data JPA source code, their save method actually does that and then just returns it, which is exactly what I'm doing here, right? Because it works with how Hibernate works and how the JPA spec works because it's all part of a transactional session. So now this thing should work. If I just issue the same HTTP request, it should just work, yeah. The whole thing is up and running. And I haven't restarted anything. I've kind of coded the whole application. So now the interesting part, let's do the profiling. So I actually have.
Basically calling the repository straight from your controller. I mean, normally you would have like a service in between.
Yeah, this is a simplified, dumbed down example.
But
you wouldn't return your.
You can have equivalent of a service also in Quarkus or something. No.
Do whatever. No, it's just applications. We don't need to stereotype or delineate between one bean type of a bean from another type. They're just all beans. And in a Quarkus application, you have far less of them than you do in Spring. So there's no reason to delineate. Spring will do like.
I mean, in Spring you'll have a controller and service and component and repository or something.
There's just all beans. The only one that's different is we call it a resource class, is @path. @path is, it's kind of an indicator that this is when you have @path at the class level, this is a resource class. So with Quarkus, you don't need to add, you could add application scope to it, and it would be fine, but you don't have to. Because it's basically telling Quarkus this is a resource class. Treat it as a resource class, so we assume that it's application scoped and it's not request scoped.
Mm-hmm.
You could make it request scoped by just doing request scoped, and that just comes from Jakarta, the Jakarta spec, which I know nothing about because I didn't do it, right? Like.
So you don't need AutoWire either, right? I mean.
No, so the Spring folks even recommend constructor injection as a better pattern. So even if you read the Spring docs, they want you to do this rather than @AutoWire. I think it's a better practice in general because.
I can AutoWire constructor also, but
yeah. Yeah, because I feel like if you're going to test the class, forget about the framework for a second. By putting a constructor with requiring its dependencies, you know how to test that class, and you know it's immediately obvious what the dependencies of that class are versus everything is auto-wired, everything is private, and now I'm trying to construct an instance of the thing, and either I have to use the testing framework and I don't even know what beans I need, or if I'm not using a testing framework, I have to use reflection to set the things, right? This is very obvious, and it makes it easy to test because now I can just create stubs or mocks or whatever, and I can
you don't need to annotate anything like it
no,
as a component or something. It just automatically presumes it's a bin or something.
Yeah, just automatically presumes it's a bean. I could, if I had multiple constructors, then I'd have to do @inject, which comes from Jakarta.
Okay.
If I didn't want to do constructor injection, if I just wanted to do This I would do at inject, and it can't be final. Right? And now it's field level injection versus constructor level injection. But field level injection, when you start talking about native image, even in Spring or any framework, if you're doing field level injection, now you have to make GraalVM aware of that class and that field, and it has to not erase the field. Whereas when you do a constructor injection, it's just there because GraalVM respects the constructors. It's statically linked at compile time, right? So it's just a good practice in general, in my opinion. In my opinion. All right. So why is this not compiling? What's this error mean now? What did I do? All right, so I compiled it, right? So now let me do the stress. Oops. I got to do it lives on a different project. Let's see if this will work. I don't know if this will work. I may have to just copy it. You know, I have the same application over here. I just rebuilt this is essentially the same app that's in our benchmark. I just rebuilt it from scratch now. But so I can go over here and let me compile it. Start database. The other kind of, while that runs, Quarkus also has a set of Spring compatibility extensions that you can use. So if you look at this code base here, this will look exactly like the Spring code. It actually uses Spring annotations, but this applies a set of adapters. It'll do build time adaptation to translate this to what I just built. And it does that at build time. So if you were to actually put breakpoints in your application, there's no Spring classes on your class path. That's kind of interesting too. I wouldn't recommend if you're going to build a new application from scratch, I wouldn't do that because it's not intended to cover the entire Spring API. You're probably going to run into edge cases where it's just not going to work. But for Spring MVC, Spring Data JPA, Spring Security, config server, all those fun stuff, it's there as well. All right, so our thing is back. So I ran the same load. Let me make this bigger. Right, so I ran the same load. No errors, so it was able to handle the load, and I've got 10,000 requests per second. So that's a 10x improvement for the same application, essentially the same application, right? If I go back over here, you know, there were 200 requests that couldn't be filled, and we're only talking 1,400. So not quite 10x, not 8 or 9x improvement, just so the throughput is incredible. And I didn't measure memory, so let's go back to my slides here, and we can talk about resource utilization. My PowerPoint go.
The application is just doing a little bit of I/O. I mean, it's not really doing much of a compute.
No, it's all compute. It's all I/O. You're right. This application is all I/O.
So why is it like 10x performance? I mean,
because they can just handle the
data,
load.
you still have the same database, right?
Same database. Same database. Same schemas.
I mean, you're limited by database performance, right?
It's database performance, but it's throughput. It can handle the load. It can, when I jam that many requests at it, it just let me do. I'm good. I'm all good. So it's very good at I/O. It's very performant in terms of I/O. So Quarkus sits on top of Eclipse Vertex. If you're familiar, Vertex is very lightweight it is very good for I/O, and Quarkus sits on top of Vertex. So Vertex is the underpinning, and under Vertex is Netty. So the same Netty that like WebFlux uses. So you got Netty, then you got Vertex, and then you got Quarkus on top of Vertex. Where did my slides go? Can't find the slides. Hidden somewhere. Ah, yes. There they are. So these numbers came from a run that come right out of the performance lab, and they're actually right here. I'll show you where they are. You can actually see these graphs for yourself. So I talked about everything is open source. So here's all the scripts that run everything. There's another repository in the Quarkus GitHub called benchmarks. So if you go into this benchmarks repository, there's results in every run that we do. So there's the latest result. So it's just a JSON, which has all the raw data that's in it. It also, of course, has a run folder, and all the logs from every application that were happened during the run is all here. And then we generate graphics. So we automatically, every time we publish this, it automatically generates all these graphics that I'm going to show you on the slide. So all these graphics are there, they're on GitHub. This is like hot off. This is what I was doing in my hotel room this afternoon, like before I come. We just kind of published our first set of runs with Spring Boot 4 today. So let me just wrap up here.
Back to the improved throughput. Is it? I'm not familiar with what is it? Cortex? Quarkus. Is it effectively like just doing virtual threads?
No, that's not. That's doing completely blocking.
What is? I didn't follow it. What? How does it get that level of improvement?
From all the build time adaptation that it does, the way it does, it improves, and it does the just-in-time compiler. There's no startup overhead. There's very little startup overhead, so you don't have that big spike. It also is very memory efficient. So like this graph, so this is RSS, the memory size. So this was running in our lab, a much more controlled environment. So the Quarkus app, on average, we ran it multiple times. You take averages and stuff. The app used 275 megs of RAM, where Spring 4 took 583, and Spring 3 took 519. That was just in normal Java just-in-time mode. Spring also has this, what they call AOT mode, which we can have a different conversation a different day as to what that actually means. But the Spring 4 came down to 568, and Spring 3 came down to 513, still way off from here. And then the native binary, when you do native, Quarkus is 76 megs, and the Springs are in the 200 meg in terms of memory footprint and resource. So if we look at time to first response, so I don't like boot times. Anybody trust, like when you start it, it says, hey, I started in 3 seconds. Anybody trust that number? They all lie. Even Quarkus lies. They're all liars, right? To me, the better metric is how long does it take to start and be able to serve one request. Because some frameworks will start eager, so they may take longer to start up, but the first request is fast. Others might start up really fast, but then you pay the price in the first request. So Quarkus, 2.8 seconds. Spring 4, 6.5, Spring 6 seconds. So a 3x or 2x performance gain here. Spring in AOT gives you a little bit here, and then in native is all pretty the same. When we start talking about throughput, when we funnel load at it, about 19,000 transactions per second, where the Spring.
Is this throughput measured over some period of time, or is it like right off the startup?
So we have a warm-up period where we just hammer the thing for a couple of minutes to get it all juiced up and warmed up, where we're not measuring, and then we do the load test. So that these things are fully warm, just-in-time compiler is fully, it's had a few minutes to kick in. And like you said, it's the same endpoint that I just showed you. It's pretty, go to the database, get all the data, serialize it, marshal it into JSON, and send the JSON back. It's one round trip to the database, get everything, follow all the joins, create the JSON, and send it. So it's a pretty IO bound test. Where'd my
has less throughput,
Yes.
but it's running native.
So I talked about that. So when you compile the native image, you actually sacrifice overall throughput because you have no just-in-time compiler. So whether you're doing Micronaut, just Java, it doesn't matter. When you build to native image, you lose throughput. It's a trade-off. So we've got almost 19,000 transactions per second, 7,000 and 6,700. So we're using half the amount of memory. You're getting 2 to 3 times the throughput. So if you start to think about this in terms of how many pods would I need if I know what my load is, how many pods do I need? Well, I know I'm getting twice as many requests per second out of it, so I need half as many apps in Quarkus, and each of those apps uses half the resources. So how would you like to save 50% of your resource utilization, right? But back to my original question, we can prove that we can actually do it. Right, and then you can see in AOT mode, you get a little, AOT doesn't really buy you anything in terms of throughput. It gets you a little stuff in startup and time to first request. It gets you nothing in throughput and buys you a little bit in memory. But the build, we also have a build time chart, which I didn't include here. The AOT version takes twice as long to build. Even though it's not building a native image, it's still Java. It just takes twice as long. So when we actually look at what these applications contain, this is the Spring 3 comparison. I'm going to go to the Spring 4 one. Right? So if we actually look at all the classes on the class path, and GraalVM will do this for you. GraalVM will spit out all these numbers for you. For your source code and all of the dependencies, the Spring Boot app has 37,000 classes. The Quarkus has 22,000 classes. Same Jackson version, same Hibernate version, the same versions of all the third-party dependencies. We do dead code elimination on the JVM before we build the app. 52,000 fields to 28,000 fields. 178,000 methods to 100 methods. If you look at the reflection, you see some of these numbers here. So we've got 44% less classes using reflection. So that means half of our thing is statically compiled and not using reflection. 95% less fields using reflection, because think of @AutoWired. Every time you do @AutoWired, that's a reflection field, right? So not just your code, but all the framework code, all the dependencies that you're using, they're doing it, and it adds up. 67% less methods that have to be reflectively accessed because we just don't do it, right? Less attack surface, just less code in general to do the same thing, right? And there's plenty of, I know we're getting towards the end here, there's plenty of companies and government agencies out here that have gone through the same example. The salespeople hate when I do.
Spring security, Spring integration, Spring Spring batch or whatever, right? I mean, does Quarkus have all that?
There's like 700 different things, and then there's community ones that aren't part of the core thing that we don't maintain. You'll find, we call it the Quarkiverse, as a separate repository called the Quarkiverse, which are just kind of third-party extensions. You'll find a lot of the core committers will maintain some of their own fun stuff too. I have one there. Just it's not related to the core thing, but it's related to something else. But just other people. There's a lot of companies like Vodafone, Amadeus. There's a lot of different companies that also contribute to this. So we've probably got about just under 100 full-time people between IBM and Red Hat that work on this. There's over 1,000 total contributors, so we're only 10% of this. And I'll talk about the foundation in a second, but there's plenty of organizations who have bought into this. And when I come to a customer and I do this talk, I tell the salespeople to plug their ears, because I say, the salespeople want me to say, you can double, based on what you're doing today, you can buy twice as much platform. I say you can get rid of half of your platform, right? And do exactly what you're doing today. So depends on if you're a glass half full or half empty person, right? Yeah, so there's plenty of case studies. This one is interesting. This customer, actually, they joined this like before we were even at V1, like 6 years ago, and they've been tracking their financials since they switched from Spring. And they publish all of how much they've saved, how much infrastructure they've saved, how much their Amazon costs have gone down, how faster they can bring features to market, and all that stuff. There's plenty of others. We're also doing as part of this open sourcing the benchmarks, we're also doing carbon efficiency and energy management. So we did a study a couple years ago, but we're trying to now open source this as well and make the results public. But we found that if you're concerned about electricity or carbon efficiency, the same app with the same load, the Quarkus will save you 2 to 3 times the electricity cost, just running the app on Quarkus versus Spring. If you want to get started with it, there's the Superheroes, which is kind of the pet clinic of Quarkus. I'm the maintainer of this. This is kind of my baby. There's lots of different stuff. It's like everything but the kitchen sink. And I also want to say, where Spring is controlled by Broadcom or whoever owns it now, Quarkus is owned by a foundation. So it's not owned by any one vendor. So the Common House Foundation is a collaboration of a lot of different vendors, and Quarkus was actually donated by Red Hat to Common House last year. So it's vendor neutral, vendor independent. Red Hat has its own productization and will sell support for it. IBM actually just announced it today, and it's coming out tomorrow. You can buy a productized version with like 5-year support from IBM, but in the community, we support it for 6 months. We have a 6-month LTS, and the community bits are owned by the foundation.
Quarkus and WebSphere?
It's an interesting question. That's a question we can take offline. Yeah, so I guess that's, yeah, and so the slides should be here, and that's all I have. So thank you. Any questions?
See if anybody online has any.
Oh, are we broadcasting live? I didn't know we were going live. I thought it was just recording. Ooh, maybe I shouldn't have said everything I said. Oop, can't take it back now. Just kidding. Any questions, or I can show anything, if you have any, I can show stuff off. I got all night. I'm just going back to my hotel. I can stick around. Yeah.
For the Postgres, you said you just added the dependencies and found like a Docker image?
Yeah, so the dev services will just, different dependencies, each extension can decide what they want to do. So like the JDBC extensions all have, it'll look on your configuration for configuration. Like if you don't configure it and it sees the dependency, it'll just go grab it from Docker Hub and start it for you and bind and contribute, we call it contributing all the configuration properties to bind it to your app. So like the username, password, the URL, and all that stuff. So there's like, there's lots of them out there, and then you can even build your own. So let me find my browser here. So there's like Redis, and there's lots of them. Yeah, so these are the ones that come from the core, like AMQP, Apicurio, all the JDBC data sources, Kafka, Keycloak, Kube. So we can even mimic the Kube API. So if you're building like a Kubernetes operator, for example, you can do that in Quarkus, and the dev service will mimic the Kubernetes API for you, so you don't actually have to deploy it to a Kubernetes cluster to test it or to run it. It can simulate all that for you. Long-running action, so if you're familiar with like the Saga pattern, there's an LRA extension in here, Mongo, Rabbit, Pulsar, Redis Vault, Infinispan, Elasticsearch. There's also, if you, everybody, I shouldn't say, do you do observability? You all do observability, right? Just nod your head and say yes, like logging, metrics, tracing, all that fun stuff. So if you use the standard stack, you know, Loki, Tempo, Grafana, Prometheus, and OpenTelemetry, it'll actually stand up the entire observability stack for you, give you Grafana dashboards right in dev mode that you can see and look at all your traces and all that stuff. Neo4j provides one for Neo4j. Do people use WireMock? WireMock is awesome. I love WireMock. There's actually a dev service here where I can just I use like WireMock Cloud, and I come up with my requests and responses. I can just blindly copy them into my source tree, and the WireMock dev service will just serve it for me. It'll just stand up a WireMock server. So either when my app is running in dev mode or when my tests run, it'll just automatically use WireMock to stand that up for me. It's cool. And Microx is a cool platform too. But then there's lots of other third-party ones that aren't listed here. I have one. Is anybody familiar with Dockling?
Heard of it.
AI framework.
It's
with
an
the
AI
documents.
document parsing framework. So it's written in Python. I am the maintainer of the Java API for that. And we have, Quarkus has an extension. It will start a Dockling server as a dev service for you. And we'll bind it to your app. And we'll even show you the Dockling UI right in the dev UI. You can click it, and then you can interact with the Dockling UI. So Thomas Vitale and I own that project. We both self-discovered separately that we were both working on the same thing. We were like, why are we both building the same thing? Why don't we join forces and build something? And you know, I worked with the Dockling folks, so we ended up pulling it into Dockling itself, so it's part of the Dockling project. But he and I maintain it. Any other questions? Yeah.
One quick question is, do you know which companies are using Quarkus? Because I haven't seen it used in a lot of places that I've been working at. But I've heard about it in the background, kind of.
Yeah, so I don't know if I can answer that on camera. So when we shut the camera down, let me talk to you. Yeah, but I know like Vodafone has been very public about it. Amadeus. So Amadeus is kind of like Sabre here in the US, where they're the back end for all the airline systems. Amadeus is the one over in Europe that all the airlines funnel all their information through. Amadeus, and they were actually a contributor to this. The government of Switzerland, Schiphol Airport, I think uses a lot of it. There are others. the challenge, especially in financial services are pretty tight-lipped and don't tell others what they're doing, which is tough to get others to do it because others won't do it until somebody else says. So it's kind of like a chicken and the egg. Any other questions?
Pull in other dependencies into my pond that are not built like these extensions?
Yeah, absolutely. So I have, any Java API, any Java library from Maven Central, you can pull down, and in JVM mode, it'll just work. Will it have all the build time optimization to make it much more efficient? No, but it'll work, right? The challenge will be in native, which would be the same challenge if you tried to use it with Spring. It may work, it may not, and you may have to go through like all those runtime hints that I had to do. You may have to do that to get it to work, and you'd have to do the same in Quarkus. So that's no different. It's not it's a painful process if it doesn't work in native. Yeah.
I guess I could promo your book, but the techniques it uses to do all this magic is in your book?
No.
No.
No, the book is just looking at Spring, looking at Quarkus, comparing them, and talking about, if I'm familiar with Spring, what does it look like in Quarkus? So, but it doesn't go into all these things. It was interesting. The slides that I had, like the secret sauce slides, I was at a conference. I actually stole a lot of the slides from Holly Cummins. I don't know if you know who Holly is. Yeah. She does a talk about things, and she and I collaborated on a lot of this. But I was at J Nation in Portugal this summer, and she was doing the keynote, and I had the first session of the day, which was this talk. And what comes up on the slides at the keynote are the same slides. I'm like, oh, sugar. Like we probably should have talked before coming.
I don't see any questions from YouTube. So anybody else?
No.
Going once, going twice. All right.
All right. Well,
so let's thank Eric again.
Yeah, thanks.
So if
you want to make the trip into New York tomorrow and want to hear about LangChain for J, I'm doing a talk in New York in Manhattan.
So can we go back to my slides real quick to finish up?
I think you were right.
Keep it short here. So
go ahead.
All right. So thanks, Eric.
You're welcome.
One thing I remembered early on, Quarkus was released in 2019, roughly, and I know before that there was Wildfly Swarm, which got renamed to Thorntail.
Yep.
And then after all that development for a few months, next thing you know, Quarkus comes in and sort of Thorntail just died. So was that just a consequence of
I came in, I'd never really worked with Thorntail. I like heard of it, but I came in, I started at Red Hat, but I wasn't in engineering, just as Quarkus was an internal thing, and then it was released in the open source community. I don't have any practical experience with Thorntail. Like I said, I skipped the whole Jakarta EE thing. So.
Yeah, right. So, plus,
I was a Spring fanboy when I came over.
So there's, competing is Jakarta data instead of, JPA.
You can use Jakarta data with Quarkus. It works fine.
Yeah.
So instead of using like that panache thing that I showed, you can use Jakarta data. It's fine.
Yeah, that's a great spec. Well, I'm one of the committers, but yeah. Anyway.
Of course, it's great.
So thanks again. So just to wrap up quickly, upcoming events. Jakarta 1 happened yesterday, but I wanted to mention it. It went from about 7 to 5 yesterday. So a lot of great talks. And QCon AI New York is in 2 weeks. I'll be there for that, covering that for InfoQ. So this is brand new. There'll be a QCon AI Boston, I think in June of next year. That was just released from InfoQ. What else we go? Wait, hold on. Oh no, that's it for now. Yeah, I'm sure there's others I'm missing. You mentioned Morocco, DevOps Morocco, and so.
The conference season's kind of winding down at this point.
Yeah, for the holidays and everything. So, and then coming up for us. So we've had some extra talks coming up we're booked through the first quarter of next year. So next week, just for clarification, we'll all meet here. Rogerio Robetti will be presenting remotely. So he's in Ireland, and so he had offered to give a talk on one of his own projects called OpenJ Proxy. So I got a preview of this. I managed to get on the docket for when he presented this at the Dublin Jug. I was able to present my Jakarta EE11 and 12 talk at the same time. So that was fun. And of course, having been in Dublin for the first time earlier this year, it kind of meant a little extra. So, and then in January, we kick off the year with Bhupendra Mishra, who's going to talk about the art of debugging in the era of AI. And this is new, Reza Ramana, who's been here with us a number of times. As I mentioned earlier, he initiated the Jakarta Agentic AI spec. And then he's presenting this at the Philly Jug this month, so I reached out to him, and you know, he was more than happy to come and visit with us in February for that. And then Victor Gamoff, he visited with us in 2017. I know we were still at the Scotch Plains Rescue Squad at the time. So, so we chose the missing protocol, how MCP bridges LLMs and data streams. So that's the talk that we chose for March. So we'll continue, you know, trying to fill out the calendar for 2026. But you know, we're in pretty good shape. You know, as I like to recall this story, and I'm sure you know you've heard this from me before. Back in the old days, you know, we weren't so fortunate to have been, you know, booking out months in advance. Barry and I will kind of look at each other and like, hey, you got something? And then he'd say, no. How about you? You got something? So we're on, you know, opposite ends of the spectrum from where we were to where we are now. So that's a good thing. It's you know, I love the fact that you know we've made the change to go on our own. You know, from the Amateur Computer Group of New Jersey and all that. So it's really been a good thing for us. So, and then as I didn't get a chance to really go through what our other friends are doing this month. I did not get a chance to run the numbers for the IntelliJ idea for November. I will do that hopefully before next meeting on December 9th. And then we'll have December. So with that, oh, and if you have not already done so, for those of you who may not have seen the QR codes, we really would appreciate it if you sign in. This also gives us an accurate attendance account, and also puts you in the running for a one-year license to IntelliJ IDEA. So if you can do that for us, that would be awesome.
I'll chime in there. This is super important for you because it helps you get speakers to come and say, hey, we've got 3 meetings a month and we have X number of people that have come. It helps attract. We have the same problem.
So yeah, it's that's what you do, the revamped Boston group. Right?
Yeah, we had a really good year. We had like 2 meetings every month this year.
Oh, nice. Yeah. Yes, I do follow your group on Meetup along with others. So yeah. So it's good. There are 400 Java user groups around the world, roughly. You know, so yeah, it's a good thing. So so with that, if you guys are done with that already, our standard ending image with craft beer and chocolate. Craft beer for me, chocolate for Barry. So good stuff. So,
all the above for me.
So let's hope the weather's good for next Tuesday on December 9th. And you know, of course, I'll keep track and keep you guys posted on, you know, how everything's going with that. And with that, safe travels home. Thanks again for coming out, and we'll see you on Tuesday.